Good afternoon and welcome to the second live interactive session for online NPTEL course Transition Metal, Organometallics, Catalysis and Biology. Myself, Subhajit Kundu, as PMRF TA, hosting this session as a problem solving session. Here I will discuss some sample problems which is related to this week. Content, that is week 2 content, and it may be some questions from the last week content. So I will wait for few minutes, then I will start discussing. So before starting, if anybody joins, if anybody have any doubt regarding this, you can ask me in every Saturday from 5 to 7 p.m. But if nobody joins, then I will continue this session from my side, and after that I will upload and you will get all the recording through the recording sheet. So whoever watching this on the YouTube, I encourage you, please join if possible, and if you have any doubt regarding the content or any other exam preparation, you can ask me in chemistry. So this is we have just started the course. This is the second week. So in this week content, we have completed a very important types of reaction which I started in the week 1, that is the Repe chemistry. Repe chemistry is the industrial handling of a gaseous species, that is acetylene, and convert it to many value added products. So Repe first introduced, but the problem was which Repe rectified is the handling of acetylene gas, which reaction is highly exothermic and the ignited in burning condition. But the use of acetylene gas is well known in the welding industry since the starting of 20th century, that is from 1906. So but their utility in chemical reaction or chemical conversion to value added product was first developed by Repe, and we discussed that there is a major four types of reaction in the Repe synthesis. So first type was the vinylation reaction, then ethynylation reaction, hydroxy carboxylation reaction, and cyclo-oligopolymerization reaction. So in this reaction we have synthesized different unsaturated product using acetylene as a reactant. Also using the cyclo-oligomerization reaction, we have seen that we can synthesize the aromatic compound like benzene, cyclooctatetraene, etc. In cycloalumination reaction, we have seen two types. One is the conventional repechochemistry, when we are having the only one type of acetylene. But if you have 2-3 different types of acetylene, their polymerization reaction leads to very conjugated or very unseparable number of mixture of products. So we developed another method, that is metallative Repe method, but that also leads to multiple product formation. We will all discuss, and in finally 2001 this problem was overcome by using the sequential addition. So all of this, and then after completing the repechochemistry, we move to another important reaction, that is the metastasis reaction. So till now nobody joined, so I will continue this session from my side, and whoever watching this video from YouTube, I ask you to join in every Saturday live session till this course run, and if you have any doubt, kindly inform or kindly ask. I will try to answer it detail as far as I can. Or if you have doubt during the lectures or assignment or question patterns, then you can ask your doubt to the discussion forum. I have already shown in the previous video or previous week session that how to ask your doubt in the discussion forum. We will try to resolve that doubt as quickly as possible. So in this course, the first week and the second week, till now we have seen two major topics. One is the repechochemistry and another is the metastasis reaction. And in this week 2 content, we mainly focus on the mechanistic pathway, that is the mechanism of metastasis reaction. So all know that the mechanism is very difficult or to understand for the metastasis reaction. So from starting of the investigation was many wrong hypothesis was published in top tier journal, but finally the correct one was come in 1971 I think, during the carbene intermediate. So we will go all of this topic one by one through the question, because as per my previous experience, it is better to understand the course through the question, and clear the doubt which appears during the problem solving thing or the questions during the exam. So till now nobody is there, so I will discuss the questions from my side. Please join if you have in the live session in every Saturday from 5 to 7. Join early in the starting of 5 p.m. and gets your doubt. So, and I find that in the week assignment for this week is slightly different from the content which has been taught. The assignment is mainly covering the next week, that is the week 3 content. But the questions in the assignment 2 is very common. I think everybody know or everybody learned it during their masters or bachelor degree courses. So that will be very simple questions which has been asked in the portal. But in my session I will try to discuss the questions which is related to this topic of this week 2. So without wasting further, I will directly go to the questions and explain their answers. So during this presentation mode, turning on video doesn't make any sense. So that's why I am switching it off. So whenever at the end, if you have any question, I will then again turn it on. Okay. So good afternoon to this problem solving session of transition metal organometallics in catalysis and biology. So the first question for today's session is the in conventional reprosynthesis the cyclotrimerization of three different unsymmetrical acetylene would give. So this question which I was discussing at the starting, that this is a problem of this cyclooligomerization reaction of, that is the reprosynthesis, one of the type of reprosynthesis, that with the homocoupled product observed, that is the multiple homocoupled and cross coupled product observed during this thing, which was not able to overcome by this conventional or metallative repre method, which was overcome later on in 2001. So he is saying that three different is showing that three different unsymmetrical acetylene. So that can be like, one is the normal acetylene, another can be acetylene with R1, and another can be acetylene with R2. So this is called, and if you have like this is, if I say R, so this is R1, this is R2, and this is R. So this is our three different unsymmetrical acetylene. So when it undergo the cyclotrimerization, or you can say that oligomerization reaction during rapid synthesis, conventional rapid synthesis. So I have said that this is gives multiple number of cross coupled and homocoupled product. So the total number, if you calculate by permutation combination, it will give 38 different homocoupled or cross coupled product. Okay, so this reaction is not very useful reaction when you have unsymmetrical acetylene. Okay. Then the next question is the metallocyclobutane intermediate in alkene metastasis was hypothesized by. That the hypothesis reaction is a very common and well known reaction. The hypothesis reaction says that if you have A, let's say an alkene, B, and if you have C, D, an alkene. So now this will undergo the metastasis reaction to give A to C plus B to D. Also, there is a possibility of making A to D plus B to C. So this is the simple example of a metastasis reaction. Now the question is the hypothesis. Hypothesis means the cyclobutane. So here you can see that there is a high possibilities of forming a cyclobutane intermediate during the 2. So this was an hypothesis. Hypothesis of what? Hypothesis of mechanism of metathesis reaction. Now the first hypothesis was given by the metallocyclobutane intermediate, which is proposed by the N. Cladron. So N. Cladron is the first proposed this hypothesis reaction. So interestingly, I am able to get that paper where this cyclobutane intermediate was proposed or hypothesized for this metastasis reaction. So I am just trying to show that paper where this Cladron shown this hypothesis reaction. This is his own paper. This one. Yes. So this is the paper, original Jack's paper in 1968. This is the original paper. Yes. Olefin metastasis acyclic vinylanic hydrocarbon. So this is the paper of Cladron. You can see here that Cladron and 1968. So this paper, from this paper in Jacks, first showed the mechanism of metastasis, olefin metastasis reaction through cyclobutane intermediate. So here you can see one thing, that it is his own paper. So he discussed this intermediate and try to prove it. But unfortunately, this mechanism proved wrong during other experiment. So this is the proof that here you can see here this is like the cyclobutane intermediate. Also here the metal is interacting with cyclobutane type of intermediate, but he failed to give the evidence of formation of this type of compound. That's why this evidence, or later on other experiment proved that this cyclobutane formation is not possible, or the metathesis reaction is not happening through this cyclobutane ring formation. So this is the original paper for this one. So his hypothesis was the claridon give this hypothesis of cyclobutane intermediate formation. So this is the second question is okay. The third is the major product obtained from the metathesis of 2-butene and butene D8. So here we'll know that the different, this question is mainly the question from the mechanism part. From the mechanism we have seen that the T2 product is obtained as a major product, and here our answer will be option number 4, that is D, and this will be the major product. We will go to the reaction mechanism in the following questions. This is the another. So this one and this one is the two experiment. One in experiment where one experiment scientists labeled the hydrogen with the deuterium. In other experiment scientists labeled the carbon atom with 14 Cu, 14 carbon atom, to exactly prove the reaction condition. So the target was to investigate the mechanism of the reaction. Okay, so the following reaction gives the basis for the understanding the bond order of CC. No, CC bond order cannot be determined from the experimental purpose or experimental, or the radioactive property of 13C. 13C is not radioactive at all. Disproportionation reaction of propene. No, this is not a disproportionation reaction, because the oxidation state of the carbon atom remains same in both the side. So for the disproportionation and comproportionation reaction, oxidation state of this species must be changed. This is not a disproportionation reaction at all. And the last is the mechanism of olefin metastasis. So as we are reading or we are learning the olefin metastasis reaction, so in the previous question we have seen that deuterium leveling experiment, that is hydrogen is replaced by deuterium to show or distribute the deuterium product ratio, and this one is carbon atom is labeled with the 14C carbon to show the product ratio or to prove the mechanism of this reaction. So here the question, the answer will be to find the mechanism of this olefin metastasis reaction. The next question is the involvement of metal carbene intermediate in metastasis reaction. Huh? First explained by so after proving the or lack of evidence for the cyclobutane intermediate for the metastasis reaction, the first proven or actual or correct metastasis reaction was proved by Yves Chauvin, who has proved that the metastasis reaction is undergo by carbene. If you have this carbene intermediate, okay, so metastasis reaction undergo by carbene intermediate was proved by in 1971, and he published this paper in, and this paper was not this one, this paper was published by 1968. So after 3 years he proved the actual mechanism of this metastasis reaction by simultaneous studying of Fischer carbene or soft type carbene. He able to prove that olefin metastasis reaction undergo by carbene intermediate. Okay. The last or sixth question is the olefin metastasis. The following mechanism is proposed by this paper. Do I have it or? No, not this one. The next question. No, this question. The olefin metastasis for the following mechanism is proposed by. This is also another wrong mechanism which was published on a top tier journal, but the assignment or hypothesis was wrong, which was proved later. So these types of methylated intermediate formation was then proposed by another scientist is by R. Petit. So these types of question are generally called the informative question, that is whether you will know or have the knowledge from this topic or not, that is the information of this topic, and these types of question does not have any understanding, only this is to remember like a story, then only it is possible to answer this question, and these types of question can be asked during the examination also. Okay. So now as I show that pattern paper, now I have also downloaded the paper for this petit, and this is the paper which is also a Jack's paper, communication paper. So here you can see that petit is the communication paper. So Petit had hypothesized the formation of this type of intermediate through this reaction. You can see that there the name, the Petit is the author. So here this paper here proposed the mechanism. This is the original paper from the Petit to the communication to the editor. Okay, let's move to the next question. The catalyst used in the following reaction is which catalyst is used for the following transformation reaction? So here you can also apply this reaction is a metathesis reaction. So the rule of option elimination can be applied to get the correct answer for this question. What is that? That if you closely look at the options, it is maybe sometime possible to omit the one or sometime two options to get the more correct two options. Let's say here if we talk about that option 1 is nickel is a complex and hydrogen. So hydrogen generally did the reduction reaction in presence. So there is no connection with this reaction with this reagent. So option A can be eliminated easily. So here in different question you can try to connect the options with the question by closely look at it, and you can eliminate 1, 2 or even sometimes the 3 option for very easier question to get your correct answer, or you can reach to the correct answer more effectively. So let's say for a question, if you have the 4 option and 2 out of which the 2 options is not even relation with the question, you can eventually, or you can first eliminate that 2 option, so your chances of getting the correct option will highly increase, that is to 50% at least. So out of 4, now I have to only give the tick on out of 2. But this question or these types of is only applicable when you have MCQ, that is multiple question type answer. For MSQ, or that is multiple selection type answer, it is difficult to predict. But don't worry, for the NPTEL course or exam, we will have to give the partial marking of multiple selection type questions. So out of which, if you have the 1 correct or 2, if you have let's say 3 correct option, you marked only 1 or you marked only 2, it will not be considered as a wrong answer, it will be considered and given to the partial marking. Okay, so the catalyst for this reaction, and this is also a reaction to which you need to recall it to get the option and answer correct. So here our answer, correct answer will be option number B, that is a rhenium complex oxide and aluminum oxide which act as a catalyst for this reaction. Now the question number next question is, the given reaction is an example of. Okay, so given reaction is an example of. So now we again go back to our from metathesis to represynthesis, and you have to do this practice multiple times, because in an exam all the content will be puzzled up and you have to remember all the content. That's why here also I mixed all the questions so that you will get a flavor of the exam. So when you are thinking the metathesis reaction, I switch the question to the previous topic, that is the represynthesis. So if you know the answer, so here you can see that our all the alkyne, that is the first alkyne, that is this one. We have alkyne, we have 1 to second alkyne and this one, and we have our metal also, and these 3 alkynes, 1, 2, 3, 3 alkyne undergoing a polymerization reaction or cyclooligomerization reaction to give aromatic ring. So for these types of reaction, when the metal is involved, is called the metallated represynthesis. So this is not the conventional represynthesis, conventional represynthesis when the metal is involved, and this is titanium metal is involved here. So this will be the metallated, and it will undergo the metallation followed by the oligomerization or cyclooligomerization. So this is called the metallated repe synthesis. So option B will be correct answer for this question. Now again we going back to the repe synthesis. So acrylic acid can be obtained by. So this acrylic acid thing I discussed in very detail in the last week 1 session, and how acetylene can be converted to acrylic acid I also show by drawing. And this question is a MSQ type question. MSQ, that is multiple selection type multiple selection type question. It is a MSQ type question. So this is a MSQ type question. So acrylic acid can be obtained by heterogeneous catalytic oxidation of propane, reduction of vinyl alcohol by LiLH4, hydrocarboxylation of acetylene, or amine oxidation of propane. So this is a multiple selection question. Okay. Let me time to recall it, and then we will discuss the acrylic acid synthesis. We already discussed in the last class, and we will again, because the synthesis of acrylic acid is very important. So the acrylic acid can be synthesized by heterogeneous heterogeneous catalytic oxidation of propane as well as the hydrocarboxylation of acetylene. Now let me go to a blank slide, or we have already discussed this during the last class or last session. That is, if you have the acetylene CH in presence of CO plus H2O in catalytic medium, it undergo the reaction to give the acrylic H2C double bond CH COOH. So now this reaction is called the hydrocarboxylation reaction. Okay, so this is the third type or one of the type of Reppe chemistry. Okay, the next question I have already said or already discussed. The next question says that the substrate required for the production of acrylic acid using Reppe synthesis. So Reppe synthesis for the substrate. So the substrate. So this question you can think. So this question is a very interesting question, and as I was saying earlier that elimination option can be possible to get the answer. So it is saying that acrylic acid, that means acrylic acid, that means a carboxylic acid group should be there, and it is saying that Reppe synthesis. So from the name of Reppe, it is already we have the acetylene. So acetylene will be one of the answer for this question. Okay, now how acetylene have how many carbon? 2. Acrylic acid has how many carbon? 3. So another carbon will come from where? That another available substrate, that is a CO, because other two substrate which can be there doesn't contain a CO. This CO should go here. Okay, so CO and acetylene is required. Should do the final workup to give the acid, we require the H2O. So option A, B and C, here 3 option is correct for this question. And this CH3CO2 you can firstly eliminate, because this doesn't undergo, this is a alkyne chemistry or acrylic acid, so this doesn't give the, cannot be the substrate for making. Okay, and Reppe chemistry, the main source of carbon atom is the our acetylene. Okay, The next question is the chemical used in portable lamps to generate the acetylene is. This is also a very good question for this rapid chemistry, or everybody should know it. These portable lamps, that means we have a special kind of lamp, and these lamps are very old lamp used in 20 or 30 or 40 years ago, 40, 50, 60 years ago, like in 1960 or 1970 or before that we are using. But after the electric lamps or the we are not using this, because I already said that acetylene gas or is highly dangerous. It ignited, when it ignited in presence of oxygen, that is 1:1 mixture of oxygen, even in the air, you produce heat around 3000 degree centigrade, which can burn or melt anything, like metals can also be melt. So due to the safety hazard, we are not using these lamps. Okay, so but in the earlier days, 1950s or before that, we have the acetylene lamps. Here we know that the main source of acetylene is the non-renewable energy sources, that is the coal, but in the lamps we are having the our very cheapest carbide source is the alkali metal carbides. Earth metal carbide are best source for this acetylene producing. So here that magnesium carbide is the source for this acetylene. When it reacts with water or very small amount of water, it produces high heat, very high heat, and it ignites and it produces the acetylene gas. Acetylene gas is not able to catch fire. If you light the acetylene gas with fire, lights up with ignited with fire, it will be a nice lamp. So acetylene gas also used earlier days as in lamps or portable lamps, where starting material or raw material is calcium carbide, which is easily available. If you put little amount of water with that in a certain concentration or certain amount in a certain time frame, it will release acetylene, and burning of acetylene creates light. So this and bright light, you can see the welding, when the welding happens, how bright the light is. So like that acetylene also light is very bright. So it can be used as a lamp. So calcium carbide is the right answer. The last question for today's discussion session is the reactants of the following reaction is. Now we have our product, we have to just find out the reactant. Also this question I discussed later, but in different method. I did not discuss this question, but the topic I discussed in last series, and today I am giving a question with it. So now from this question we can also think one thing, what, that this moiety, that is here, here oxygen, oxygen, double bond, this moiety. So this moiety, if you break it or look closely, that this moiety is similar to this one, either this or this, okay, and the other part is coming from this one or this one, okay. So you can say that so both is required, okay. Now see this skeleton carbon atom. So this has 1, 2, 3, 4, 5. 5 atom we have. 5 carbon atom, 5 carbon system. So now out of this 5, whatever we take, B or D, so any one from this, we have 3 carbon both. So any one will have to take from this set. But from this one has 1, 2, 3, another has 2. Okay. So possibility of this star group is less, so we can eliminate that, okay, because this lone pair of oxygen in both the cases try to act as binding for further reaction. So we can only, so option C will be our one of the product. Now we are getting this vinyl ether. This is called VINYL, vinyl ether. So this vinylation reaction is known for acetylene, simple. But this is not acetylene, this is ethane. This is double bond. The Reppe synthesis of this chemistry only possible with the acetylene. So option D will be the correct answer. So option C and option D is the correct answer for this question. Now if you want to explain the mechanism, I have already discussed it. So if you have R, C double bond O, OH, so in presence of catalyst, it and R, 2, C triple bond, CH, this is R1, this is R2. So the possibility this oxygen can attack to this carbon, also these can attack to this carbon, okay. So let's say this is method or path A and this is path B. So for the A path, when this will attack to this carbon, what will happen? So R1 C double bond O, hydrogen will remove, and this one bond will open to the terminal C. So this will be C double bond. So this triple bond will reduce to double bond, and this OH hydrogen will take up this. So this will be like CH2 and here R2. This is the one product. What will be the another product? That is R1 double bond O, it will get up to this. So O, this carbon, then this carbon, then this carbon, R2. Okay, so this will be our product B. So if we use the catalyst ruthenium at minus 80 degree centigrade ruthenium catalyst, we observed only the product where this type of attack. This is the not established mechanism. This arrow I have drawn just to show or just to have an idea. Okay, so this will be the major product, almost 93%, and this will be minor product. Okay, so with this I completed 12 to 13 question. From this week topic, and let me see if anybody have any question, you can ask me. Anybody have any question, you can ask me. I will happy to answer. Okay, so one person joined, but I think left. Okay, okay, no issue. So now okay, I have completed 12 question from this week, but I think I have to discuss little bit of this week content so that week 3 content, so that it will be easier to assign or answer the portal question, because I find that portal question is not related to the week 2 question. Actually it is mainly from the week 3 question, week 3 content. So before going to discussing this, and this question is very general question, so anybody can answer it. If you have any doubt regarding this portal assignment or lectures, you can post that doubt in the discussion forum. Also you can ask me, but if you have any doubt in my question answer series or this problem solving series, if you watch from the YouTube, you can ask me directly or you can mail me. I have already given the email address in the starting, so email address I have given. So in that email address you can drop a mail. I will try to answer it, or it is better if you join in every Saturday 5 to 7, mainly 5 to how much I can. So So to better understand your content of that week, and also get an idea and what type of question can be asked during the examination time. Okay, so now it's time to discuss the some more or most important content of this week which I have not covered in the question answer. Okay. So I can give my email address here. So that if you have doubt in the YouTube, if when you watch this content from the YouTube, you can mail me, or you can, if you are unable to join, if or but it is better to join in live mode and get your doubt clear. I will try, or also if you have any suggestion regarding this session, you can also tell me. You can tell me during my live classes. So now let's discuss some important topic which has been covered in this week but not discussed through the question answer. So in this week we have mainly see the metastasis reaction, the history of metastasis reaction, and we have seen how some wrong hypothesis is published and how in same year both are wrong, but how they are published, and also at the end how the right one got accepted by everyone. And the topic of other related synthesis or related metal carbon complexes can emphasize in this text. Okay, so for that three people, Chauvin, Grabs and Shork, got the Nobel Prize in this area. One topic mentioned in the lecture that the metastasis reaction is undergo by non-pair method. That is, it is not happening like the cyclobutane method or like that what Petit says, that also not happen. And according to Chevin, it undergo the metal carbene formation mechanism. So mechanistic consideration, if you do the formation of different product and the predicted them the product ratio by isotope leveling experiment, one can easily prove that it happened via non-pairwise metal carbene intermediate stage. Let's say, for example, we have a metal carbene intermediate X is bound to metal M, and we have another olefin A, B. Now the reaction between these two happen in different way. If this orientation, this is fixed, so this will give one product. If the orientation of AB changes, that will give a product. So for the first one, it will give X, M, A, B, M. So now this will dissociate faster to give X, A plus metal B. Okay. So now this is another species generated, or another metal carbene species generated in the system, and if it undergo the other possible way, that is B, A. So now if this one react, it will be X, M, A, B. Okay. Now this will generate X B plus double bond A metal. Now this can again undergo the cross couple reaction with this. So that's why, due to the generation of different metal carbon species in the intermediate, we are calling it at chain reaction. Now consider the another example. Let's say if you have it deuterium labeled hydrogen, deuterium labeled hydrogen, then this hydrogen easily converted to the cyclohexene ring, which is generally unreactive and giving the deuterated ethylene. Okay, deuterated ethylene. Now it's react with another ethylene of this molecule, and this will generate this thing. Okay, now this one can undergo different process to give different deuterated isomer. Now depend on this deuterated isomer formed in the reaction, we can have a ratio of the product, and from that we can predict which will be the major product in the reaction, or which mechanism the product is going, or the mechanism is going in major amount. So first number product will be, if we exchange the hydrogen with this, so then the metal will come into here, so then the product will be first it will be CD2 and metal will give this. Metal will this. So that will be a metal and D2 product, because we have exchanged 2 deuterium with hydrogen. So that is D2, and if this doesn't change, okay, this doesn't change, so this is D2, this is called D2. Now if These again undergo the exchange. We will have, like if we dissociate from this thing, we will have CD2 double bond CD2. So this is D4, and if from this system this undergo flipping and the rest of the deuterium also undergo exchange with this. Okay, so that will generate another product, that is without deuterium. So that is D0. So if you consider the ratio of 1 that is D, if you consider the ratio of D4, D2 and D0, it will be 1:2:1. That is the experimental proof of Chauvin. Okay, so for that we can say that D2 product will be maximum amount in this metastasis reaction. So this gives answer to the first question which I discussed in today's series. That's why I told you that I will discuss during the mechanistic investigation study. And why it is chain reaction? I have also said that the possibility of forming multiple species, let's say if you have two alkene, that is A, B and C, C, D. Now let's break this to form metal double bond Cr, metal carbene and CHR, whatever, CHR. Now this metal carbene Cr, metal carbene intermediate. Now from this reaction with one carbene, that is M, if you have M with X another, so this will generate multiple 4 reaction, mean already 4 metal intermediate. This is one, and if you do the cross metastasis reaction, it will undergo the metal carbene intermediate, and this will generate huge number of different number of, so one will be M A M so this will generate different number of reactive species. So different number of reactive species will be generated. So that is M double bond, this one we have M double bond A, M double bond B, M C, M D. That's why this reaction is also naming as a chain reaction. So with this, I think I have discussed all the questions and the important point from this week content. And if you have any doubt, please ask me in the next live session, that is next Saturday from 5 to 7 p.m. And if you have any suggestion regarding this session, or that means how to improve this session quality, you can also discuss with me. These assignment questions I will upload, and you will get the link in the Google Drive. Okay. So now let's just summarize this session. So today I have discussed 11 to 12 question, which is totally on this week 2 content, and some of the question from the continuation of the week 1. So this question will be helpful to better understanding for this week assignment question, and to solve it and give an idea how what type of question can be asked during the final examination. I thank you everyone who will watch this session in the offline mode, that is in the uploaded version. So if you have any doubt, please try to join me in the live session. I will happy to have your doubts and try to answer as detail or as easily I can. So this today's or this week's session is not that much difficult, I believe, but on the upcoming session it will be more interesting. We will discuss little bit about more carbon chemistry, and we will continue with the metathesis reaction, and then we will discuss some carbon chemistry, which is I believe the most or more interesting or vital thing and all, and also discuss some of the mechanistic part of it. We are now only talking about the metathesis reaction from the uh, for the uh, uh, for the ethine, that is the C double bond, but for the alkyne alkene only we are discussing, but the alkyne we will discuss in the later on. Also discuss some important organometallic compound in the next session. So I think this is enough for today. If you have any doubt, just ask me, or for the lecture series or question portal assignment doubt, just post it in the discussion forum. It will be helpful for you, or whenever we will get the thing, we will answer it. Okay. As nobody joined, so I will stop this session within few minutes. Thank you again for joining. Hope I will see some of you in the next live session. Thank you. Okay, till then nobody is here or nobody joined or wait in a waiting list, so I am stopping this session now. See you in the next Saturday 5 to 7. Thank you.